Now let's get the basics right around ratio. But what is it? Well, first things first. A ratio is a comparison between two halves. It's a way of expressing the relationship between different quantities. Ratios can be written in different forms, including as a fraction, decimal, or percentage. Now, when it comes to a fraction like the one you see on the screen here, a fraction represents a ratio by dividing one quantity into the other. In this case, we've got 3 and 4, in other words, 3/4 as our fraction. So in this example, the fraction 3/4 represents the ratio of 3 parts to 4 parts. What about decimals? Well, if we take the same fraction and we change that to a decimal, we've got 0.75. Now, a decimal is a ratio expressed as a number with a decimal point, as we've seen over there. This represents the same relationship between quantities as a fraction, but it is a different way of expressing it, so it's still the same thing. In this example, 0.75 represents the ratio of 3 parts to 4 parts. Remember, we said at the beginning, it can be expressed as fractions, decimals, and percentage. And speaking of which, here's the percentage. So here we have 75%. Now, a percentage is a ratio expressed as a fraction of 100. It's a convenient way of expressing ratios when we're talking about proportions of a whole. In this example, 75% also represents the ratio of 3 parts to 4 parts. So what we find is that ratios are everywhere in our daily lives, from taking baking recipes to understanding stock prices. For example, a pie chart can represent the ratio of different categories in a data set, and there you can see a typical example. So with that said, let's go and do 1 or 2 practical examples to see how we actually work this out. Now, in our ratio examples, first of all, don't forget that we are going to use the colon. So here we have the ratio of sand to cement, 2:3, which means that for every 2 parts of sand, we will need 3 parts of cement. Here's another example. The ratio of boys to girls is 4:3. If there are 20 boys, how many girls do we have? So the first thing we need to do now, we have our original ratio in place, and we want to get to our result, which is, remember, this is boys to girls, right? So we want to find out, if we have 20 boys, how many girls do we end up having? Well, what did I do in order to get from 4 to 20? I multiplied by 5. And again, what I do on the one side, I've got to do on the other side, multiply that by 5, and I end up with that ratio, which means if I've got 20 boys, I have 15 girls. So what I can also do is say, well, I need to find out how many girls there are for 20 boys. I'm going to divide it by what I currently have in terms of the boys, and whatever that answer is, I'm going to multiply it by the figure I have for the girls. What do I end up having? 5 by 3, and there again I have 15. Here's another example. We've got a ratio of teachers to learners. 2 teachers to 66 learners. Now, when we look at this ratio, we can already simplify it and say, well, if it's 2 teachers to every 66 learners, and we want to bring it down to 1 teacher, what did we do? We divided that by 2. We're going to divide this side by 2. And that means there's a ratio of 1 teacher to every 33 learners. Again, if I want to find out something like, well, what's the ratio going to be if I have 30 teachers? Then I'm going to divide that by 2, by what I have. That's going to leave me with 15. I'm then going to multiply that by 66. And that will give me my answer in terms of the number of learners.